This is Unit 3 of Python programming, titled Python Functions and Modules. In this unit, we learn how to divide a large program into smaller parts using functions. Functions help us organize code, reduce repetition, and improve readability. We will also learn about variable scope, which tells us where a variable can be accessed. Later in this unit, we will work with lists, tuples, dictionaries, and also learn how to work with dates and time. Finally, we will understand modules, including how to create our own modules and how to use external modules. This unit is very important for writing structured and professional Python programs. A function in Python is a block of code that performs a specific task. Instead of writing the same code again and again, we write it once inside a function and reuse it whenever needed. Functions help us divide a large program into smaller and manageable parts. This makes the program easier to understand, debug, and maintain. For example, just like a calculator has separate buttons for addition and subtraction, a program can have separate functions for different tasks. In Python, a function is defined using the keyword def. After the def keyword, we write the function name followed by parentheses and a colon. The code written inside the function must be indented, which tells Python that this code belongs to the function. In this example, we have defined a function named greet, which prints a welcome message. At this stage, the function is only defined, not executed. To execute the function, we need to call it, which we will see in the next slide. After defining a function, we need to call it to execute the code written inside it. Calling a function means telling Python to run that function. We call a function by writing its name followed by parentheses. In this example, when we call the greet function, Python executes the print statement inside the function. As a result, the output, hello, welcome to Python, is displayed on the screen. The same function can be called multiple times without rewriting the code, which saves time and effort. After defining a function, we need to call it to execute the code written inside it. Calling a function means telling Python to run that function. We call a function by writing its name followed by parentheses. In this example, when we call the greet function, Python executes the print statement inside the function. As a result, the output, hello, welcome to Python, is displayed on the screen. The same function can be called multiple times without rewriting the code, which saves time and effort. A function can accept more than one argument. In this example, the function add takes two arguments, a and b. When we call the function with values 10 and 5, these values are assigned to a and b respectively. The function then adds the two values and prints the result. The output displayed on the screen is, sum equals 15. Using multiple arguments allows us to perform operations involving more than one input. So far, we have seen functions that print output directly. Now we will see functions that return a value. The return statement sends the result from the function back to the calling statement. In this example, variable scope defines where a variable can be used in a program. There are two main types of variables in Python, local and global. A local variable is created inside a function and can be used only within that function. A global variable is created outside the function and can be accessed both inside and outside the function. In this example, x is a global variable, so it is accessible everywhere. The variable y is local to the function show, so it can be used only inside that function. Understanding variable scope is very important to avoid errors in large programs. Functions in Python can also work with lists and tuples. Instead of passing single values, we can pass an entire list or tuple to a function. In the first example, a list of marks is passed to the function, and the sum of all values is calculated using the sum function. The output is 240. In the second example, a tuple is passed to a function and printed as it is. Using lists and tuples with functions is very useful when working with multiple data values together. Functions in Python can also accept dictionaries as arguments. A dictionary stores data in the form of key and value pairs. When we pass a dictionary to a function, we can access its values using keys. In this example, the dictionary contains student details such as name and age. The function reads these values using their keys and prints them. Using dictionaries with functions is very useful when working with real-world data like student records or employee details. Python provides a built-in module called datetime to work with date and time. By importing this module, we can get the current date and time of the system. In the first example, the now function returns the current date and time together. In the second example, the today function returns only the current date. Date and time functions are commonly used in applications such as attendance systems, logging, and report generation. A module in Python is simply a file that contains Python code. Modules help us organize our program into separate files, which makes the code easier to manage and reuse. Python provides many built-in modules such as math, datetime, and random. In this example, we import the math module and use the square root function from it. The output shows the square root of 25, which is 5. Using modules allows us to use ready-made functions without writing code from scratch. Apart from built-in modules, Python also allows us to create our own modules. An own module is simply a Python file that contains functions or variables. In this example, we create a file named my_module.py and define a function inside it. Then, in another program, we import this module and use its function. The output shows the correct result, which is 15. Creating our own modules helps us reuse code and keep programs well organized. Apart from built-in and user-defined modules, Python also supports external modules or packages. These modules are not available by default and must be installed using the pip command. External modules provide powerful features for real-world applications such as data visualization and data analysis. In this example, we use the matplotlib module to plot a simple line graph. When the program runs, a graph window appears on the screen. External modules make Python very powerful and widely used in engineering and research applications. Function-based programming means writing a program using multiple small functions. Each function performs a specific task, such as addition or subtraction. In this example, we have created two separate functions for addition and subtraction. The main program calls these functions and displays the output. This approach makes the program easy to understand, test, and modify. Function-based programming is widely used in real-world Python applications. In real-world Python programs, we often use functions and modules together. Functions help us divide logic into small tasks, and modules help us separate code into different files. In this example, the multiplication function is written inside a module file. The main program imports the module and calls the function to get the result. The output shows the correct multiplication result. This type of programming makes the code reusable, organized, and easy to maintain. Thank you for watching. Like, subscribe, and comment.